Hi, so let's start this section by talking a bit about Terraform. Terraform is basically an open source software that is generally used to create architecture, or should I say infrastructure. It's widely used across most of the cloud providers these days, and it has become a sort of a standard for creating infrastructure in cloud. So you can see Terraform that is used widely across most of the major cloud providers that include Azure, GCP, and AWS. So what makes Terraform special is that it is absolutely simple to use. You can probably master it within a week if you have the right resources. So Terraform basically consists of an input, which is basically a configuration file. And that configuration file, when it is deployed or in Terraform jargon, when it is applied, it creates infrastructure within that particular cloud provider. So in this particular course, I'm going to give you a lot of examples, a lot of assignments, and a lot of quizzes for you to absolutely understand and to get into details about Terraform. Now, once you've completed this course, I am guaranteeing you that you will have absolutely no problem in figuring out anything about Terraform. So I hope you have a nice time and I hope you enjoy this particular course. And please do not forget to give me a rating for this course as well, as I have put in a lot of effort in making most of these slides. So thank you again and I hope you have a good time.
Okay, so now that you know that Terraform is used to create infrastructure in multiple cloud platforms like Azure, GCP, and AWS, let's talk about a few advantages of using Terraform. The most important advantage I feel is that Terraform is a very simple tool to learn. You could probably master it within a few weeks, if not less. The second advantage of using Terraform, I feel, is the HCL, that is the HashiCorp configuration language. So this is a custom language that they use to build their code. So HCL is a very simple language to learn and it's much simpler than using JSON. Of course, you have the option of writing your Terraform script in JSON, but HCL is a much better and a more preferred language. And all the examples that I would teach you would be in HCL. So look out for the HCL chapter and you will realize how easy and simple it is to use HCL. The third advantage of using Terraform is that it has providers for all the cloud platforms. So basically, HashiCorp works with most of the major cloud providers, including GCP, AWS, and Azure. And these providers make it possible for Terraform to communicate with these cloud vendors to create architecture. So these cloud providers have a close collaboration with HashiCorp to create the Terraform providers for their respective cloud platforms. It is arguably the best tool for creating cloud-based infrastructure, and it is also agentless. So what I mean by agentless is, let's say you're creating a virtual machine using Terraform. Now Terraform will not have its piece of code within those virtual machines. So Terraform doesn't work like how Puppet or Chef works, where those platforms do have agents within each of those virtual machines. So Terraform is basically an agentless tool. Okay, since Terraform does not have any agents running within virtual machines created by them, it is not recommended to use Terraform as a configuration tool. A configuration tool is a tool basically which is used to insert, update in software or programs or applications within virtual machines. But it does combine with other tools like Ansible to do the same. So you can always consider Terraform to be a tool that is to be used specifically for creating infrastructure, and it's not advisable to use Terraform as a tool for configuring software or applications within virtual machines. So that is one of the disadvantages of using Terraform. So if you have used any of the cloud vendors, you know that these cloud vendors do provide native infrastructure as a code tool. For example, if you're using Azure, Azure provides a tool called Azure Resource Manager, which has templates, which is also written in JSON. And if you're using AWS, AWS has its tool called CloudFormation and GCP has its own CloudFormation. And most of them are either written in JSON or YAML. Now, what makes Terraform special is that if you learn Terraform, then you have the potential of creating infrastructure in any of these tools without having to relearn anything extra. So all that you need to do is you need to just change the provider name and the resource configuration. So using those two changes, you can create infrastructure in any of these cloud vendors. So it's just one language that gives you the capability of creating infrastructure in any of these cloud vendors. If you are a DevOps engineer, then it's imperative that you learn a tool like Terraform, which will give you a more holistic view on how to create infrastructure. Unlike if you're creating it using the native infrastructure as a code tool. Another very important factor about using a code like Terraform is the simplicity. So Terraform is specifically built for creating infrastructure, whereas a tool like Deployment Manager or even CloudFormation is very complex. And if you go through the code of CloudFormation or Deployment Manager, you'll understand the complexity and the sheer number of lines that it takes you to create architecture. Whereas if you look at a tool like Terraform, since it's specifically built for creating infrastructure, it is more well thought out and it's a much simpler tool to learn. If you look to your left, it is a code to create a virtual machine in Azure. And if you look to your right, I have just copied a snippet of code to create a virtual machine in Azure Resource Management template tool. And it takes a much longer time to create infrastructure using the ARM rather than using a tool like Terraform. So now if you have used any of the cloud providers, you know that each of these cloud providers also provides CLIs or REST APIs to create resources. So why would you want to use Terraform instead of using these CLIs or REST APIs to create resources? Well, the idea behind that is idempotence. The REST APIs and the CLIs are not inherently idempotent. So what that means is, let's suppose you've run a particular piece of code and by accident you run that piece of code again. Now, if you run that piece of code again, it should not throw an error or it should not run again and create the same resource again. Now that is where Terraform comes in handy. So if in Terraform, if you create a resource and if you run it again, it will not throw an error. It will just say that this particular resource has been created and it will not create that same resource again. So here is an example of how a non-idempotent code would look like. If you run it once, twice, or thrice, if you can see that the payout happens every time. So there's $100 that gets deducted. Now, of course, it could either mean that $100 gets deducted or the entire application fails. So that is, in a sense, a non-idempotent code. And if it's an idempotent code, if it runs, it'll just deduct the money once, and the next time it'll just skip, and it will not create the resource or it will not do anything inadvertent again. So let's look at an example of this. Now here I have a piece of code that creates a network in GCP. So let me do a Terraform apply. So Terraform apply is a command to create a resource. So I'll do a Terraform apply once and let's see what the output is. So here is a piece of code in Terraform that creates a virtual network. So let me do a Terraform apply. A Terraform apply command is to create a resource. So let me run this particular command once. I just need to give yes. And you can see that the resource got created. So it's mentioned here that the resource has got created. So let me run the same command again. So it just doesn't do anything. It just has a very graceful exit and just says that the apply is complete and everything is as it should be. Now let's run the same command using the GCP CLI. So here is a command to create a network using the gcloud CLI. So let's run this particular command once. So you can see it got created. So let's run the same command again. So it throws an error saying that this particular network already exists. Now this was not a very graceful exit. So let's suppose you want to use this command in your script. Now there would be hundreds of errors that you would need to handle. Now that's one of the reasons why you would prefer to use a tool like Terraform instead of using these CLIs or SDKs to create resources. So I hope this was a useful lecture. I'll see you in the next lecture. Now we can install Terraform in Linux, in Windows, as well as in OS X. So there is a link on how you can install. The link I will send in the description below. So you can just go through this particular link and get your Terraform installed based on whatever operating system you have. Okay, so now let's talk about the root module. So modules are basically containers for multiple resources that are to be used together. Well, in layman's term, it's basically the folder which will contain your code. The important files here that you need to worry about is basically the main.tf, the variables.tf and the outputs.tf. So the main.tf is basically the file which will contain all the code that you need to create configuration. Variables and output.tf is something that I'll teach you later on in the course. That will be taught in the next section, so let's not worry about it right now. So let's go ahead and let's talk about all the main commands in Terraform. Now let's talk about the three most important commands in Terraform. Those include the Terraform init, the plan, and the apply. So let's go through them one by one. But before we do that, let me show you a sample code in Terraform and what it looks like. A Terraform code will always consist of a provider and the configuration for that provider and a resource block. So the resource block is arguably the most important block, and it is this block which actually creates the infrastructure that we need. So for example, in this particular resource, what we are creating is a VPC network. And the name of this VPC network is VPC network 2. Now, of course, I will be going through these blocks in more details in the later chapter, but this particular chapter is just to explain to you all the three important commands in Terraform. So what does the Terraform init do? The Terraform init downloads all the dependencies for this code. So those include all the providers and all the dependencies for those particular provider. So if you go through our folder structure right now, it just consists of the main.tf. Whenever I run the Terraform init, it will also download all the code within a .terraform folder. So let's do that. So I'll run the Terraform init command. So as you can see that it's initializing the backend. So let's wait for this to get over. So if we again go through this, you can see that there was a folder that got downloaded, and this contains all the provider related code. Okay. So the next command we run is called the Terraform plan. Now what the Terraform plan command tells you is that these are the resources that will be created by this particular piece of code or by this particular main.tf. It does not create those resources, but it will tell you in advance that these are the resources that we will create. So for example, in this main.tf file, there will be one resource called the VPC network that will be created. So let's see what happens when we run the Terraform plan command. So if you go look at the output, so the output that we get would be something like this. It will say that the Terraform will perform the following action, and it will create a VPC network, and the name of the VPC network would be this, and all the other parameters would be known only after you run this particular Terraform command to create that particular resource. So how do you create the resource? So now we know that we've initialized the backend, we've done a Terraform plan to know that these are the resources that will be created. So let's create that particular resource now. So to create the resource, we need to run the Terraform apply command. And then you need to add, and then you need to enter yes. And it's currently creating the resource. And finally, once your Terraform apply is finished, you can actually go back to your GCP console and check whether your network has been created. So you can see that a network has been created. So this is the basic default network, which has a subnet within each region. So this was a very brief introduction on how Terraform works. In the next chapter, I will show you how you can connect your Terraform with your GCP network. So in this particular lecture, it was already created, but there are multiple ways to connect your Terraform with GCP, and that will be shown in the next particular lecture. So I'll see you there. Okay, now let's talk about how you can connect Terraform with GCP. Now there are 4 ways in which you can do it. The first and the most easiest way is to use your user-based credentials. Now in the next lecture, I'll be showing you how that can be done. And the best example of this is if you're running your Terraform locally, then the easiest way to get things moving is to just use your user-based credentials. However, if you're running Terraform on a GCP virtual machine, then you should use your service account. Now, service account makes it much simpler for you because you do not have to worry about moving credentials here or there. So if you're running your Terraform on a GCP resource, then the best way to do it is using service account. Now you could also use your service account credentials, that is the service account keys, to connect your GCP with Terraform. Now you would want to do that if you're running it, let's say if you're creating a CI/CD and if you're running your Terraform in an instance that is not within GCP. You could run either using your credentials directly or you could impersonate a service account. So I'll be showing you those two versions as well. So let's go ahead and let's see how you can run your Terraform locally on your machine using just your user-based credentials. Now for this particular chapter, you'll be needing gcloud. Now gcloud is basically the CLI that you need to connect to your resources. So in the resource and the description below, I'll be giving you a link on how you can download gcloud. So the easiest method is using a user credential, and the command you need to use is the gcloud or the application default login. Now just remember that you should be using this only if you're running this or if you're running Terraform in your local, or if you just want to try it out. In production, it's much better to use a service account, which I'll be discussing in the third and the fourth chapter of this particular section. So gcloud or the application default is basically a way to create user credentials and store them in a particular path, and then your application would be using those credentials to create resources. So let's run this particular gcloud command. Then you need to access using your particular user account. So this is my user account, so I'll be using this particular user account. I'll click on allow and I am logged in, and if I go back to my console, it will state that my credentials are stored in this particular path. And if you want to view your credentials, you can go to your particular path and view the credentials. So that is about it. You have connected your Terraform with your user account. So if I want to run a Terraform apply, you can see that I'm able to connect that particular resource. So like I said before, this is the easiest way. However, it should be avoided in a production environment, and a service account is a much better option to do it. So I'll see you in the next lecture. And I'll also be posting a link to that particular command in the resource and the description below. Okay, so in our last lecture, we saw how we could use a user-based credentials to connect Terraform with GCP. Now in this particular lecture, we'll see how we can use a service account to connect Terraform with GCP. So the first thing you would ask is, what is a service account? So what is a service account? A service account is a special type of Google account which is intended to represent a non-human user, and that needs to authenticate and be authorized to access data in Google APIs. So here what we would do is we would create a virtual machine in GCP and we would give that a service account, and that particular service account should have all the necessary permissions to connect Terraform with GCP. So let's do that. So we'll go to our GCP console. So I've logged into my GCP account. So the first thing I'll do is I'll create a virtual machine. So I'll click on virtual instances, and here let me click on create instance. So I will choose N1. I'll choose the cheapest configuration. And here the important thing to note is that there is a default service account that is attached to a compute engine. So what I'll do is I'll allow not the default access, but I'll allow full access to the cloud APIs. So, but this is not recommended for production. In production, you should just give access to the APIs that are needed. But just for the sake of this demo, what I'll do is I'll create the default service account to have full access to the cloud APIs. Now, of course, you can create your own service account. That I'll teach you in the next particular lecture. So in this particular lecture, what I'll do is I'll just use the compute engine default service account. And that's about it. Let me just create my instance. So I'll wait for the instance to get created, and then I'll log on to the particular instance and I'll install Terraform. So let's wait for this particular instance to be created. Okay, so the instance has been created. So what I'll do is I'll just view this gcloud command and I'll run it using the Cloud Shell, which is the easiest way to do it. So let me open the Cloud Shell. So once you've logged into the machine, the next thing you need to do is you need to install the CLI. So there is a website to install the CLI in Ubuntu. So you just need to copy these 4 commands. So let me just do that. So let me just copy these commands and install Terraform in my virtual machine. Okay, so I've installed Terraform. The next thing I need to do is I need to check whether it has been installed. So let me just do a Terraform/v-v. So you can see that Terraform has been installed. So the next thing I'll do is I'll just copy this particular file in my virtual machine and I'll just do a Terraform init and apply. And without any extra authentication, I should be able to create this particular resource. So let me just do that. So I'll just copy this. I'll create a new folder. Okay, I need to go to that. The first thing I'll do is I'll run the Terraform init to get the provider. So let me do an ls. So if you do an ls -a, you can see that the .terraform folder has been downloaded. So now let me do a Terraform apply to actually create those resources. So Terraform apply, I'll do a yes. So here you can see that I was able to create that particular VPC network, and I was able to do it without any extra configuration. So the only thing I did was I just had to provide the service account and give it enough access to create the resources. So that's how you do it. If you're using a GCP resource, you should always use a service account, and you should never use a user credential like we did previously. So I'll see in the next lecture where I'll teach you how you can create a service account and use that particular service account's keys to connect Terraform with GCP. Now in this particular chapter, I'll teach you how you can use your service account credentials to connect GCP with Terraform. Now the only difference between 1 and 3 is that in number 1 you are using your user-based credentials, whereas in number 3 you'll be using the service-based credentials, and you can run both of them in an environment that is outside GCP, so you don't need to run it on a virtual machine in GCP. So let's first create a service account, then we'll generate a credential for that service account, and then that particular service account credentials will be used in our Terraform. So let's start. So the first thing we'll do is we'll create a service account. So I go to my GCP. You can go to IAM and admin, and within that you will find service account. So you can just open that. So first thing we'll do is we'll create a service account. So let me do that. So you can just name your service account. So I'll just call this as Terraform Service Account 1. I'll click on create. Okay, so the next thing we need to do is we need to assign a particular role for this service account. So let's keep it simple and let's just give it owner access. Just make sure that if you're running it in production, just give enough access and not more. You can click on continue and you can click on done. You don't need to do anything here. So this is the service account that you've created. So you can just open this, and under keys, what we need to do is we need to create a new set of keys. So you can just click on create new key, and you can opt for the JSON and click on create. And what you get is a text file with all the credentials that you need. So you need to copy this and you need to provide a path for this in your Terraform main.tf. So let's do that. So I'll just save this. So the first thing I'll do is I'll just rename this file. I'll just call this credentials JSON, and I will save it in the same path as my main.tf. So if I open this particular, so you can see that I've saved this particular JSON file. So I just need to access this file. So once you have your credentials.json file, what you need to do is you need to go to your provider and you need to give that same specific path. So I've done that. So basically the credentials is pointing to the credentials.json file. That's about it. So the next thing you need to do is you can just run the Terraform apply again. So what I'll do is I'll create another VPC network. So I'll create VPC network 3 and let me see if this works. So this will take the credentials not from the user but from the service account credentials. So let's try to run this. I'll do a yes. So you can see that the resource has been created. So this is how you can use your service account credentials to create resources in Terraform. So I'll see you in the next lecture. Fourth way of configuring Terraform with GCP is using impersonating service accounts. So let's go through the documentation and see why we would want to impersonate service accounts. So what happens while you impersonate your service account is that it creates short-term credentials that allows you to assume the identity of a GCP service account. A few use cases include, for example, instead of providing an external caller with permanent credentials of highly privileged service account, what you could do instead is provide temporary emergency access and that temporary emergency access can be provided through impersonating service accounts. Let's go to our console and let's see how we can impersonate service accounts. For impersonating service accounts, we need to create two service accounts. The first service account would have all the credentials that you need, and the second service account would be basically the one which you would send to the external user, and that particular service account would just have the capacity to create short-term temporary credentials. So we already have created the first one. So this was a service account we created in our previous chapter. So we would be using this as the main service account. So let's create another service account that would create tokens for this particular service account. So for that, let me just create a new service account. So I'll just call this delegate Terraform service account. I'll click on create. So I don't need to do anything for this particular service account. I'll just click on done. Now what I need to do is I need to go to my main service account. That is the one that I created previously. I'll open this. And here I need to go to permissions. What I need to do is I need to grant access. So if I click on grant access, and here I need to give the service account that I've just created the capacity to create the service account token creator. I'll click on yes. And that's it. So what permission I have given is that this particular service account that I've created has the capacity to create a service account token for this particular service account, the Terraform service account. So what I need to do now is I need to go back. I need to access the delegate Terraform service account, and I need to create a key for this. And this key I will use in my Terraform code. So I'll click on create new key, click on create, close. And again, like previously, I just copy this to my main.tf file folder. So let me do that. Okay, so I've copied my delegate.json file to my main.tf folder. So the only changes that I need to make to my provider is this. I need to change the credentials. So earlier it was pointing to the credentials.json. So this was the main service account. So instead of using this, we'll be using the delegate.json service account. And the other important key that I need to populate is the impersonate service account. And this impersonate service account should contain the value of the main service account. So this is the service account which has all the credentials or all the roles and permissions. But the only difference now is that the credentials for this service account is not provided in the credentials. Instead, it is the credentials of the other service account which has just the provision to create tokens for this particular service account. So let's create this particular resource again. So let's create the VPC network again, and let's see if you're able to create it using temporary credentials. Again, let's do a Terraform apply. I'll do a yes. And you can see that I was able to create the resource. So this is how you create resources using impersonate service accounts. I hope this was useful, and the code for this particular chapter would be given in the resource below. So I'll see you in the next lesson. Another very important command in Terraform is called as the Terraform destroy command. So using Terraform, you have created a few resources and now you want to remove them. So the best way to do it is using the Terraform destroy command. So here in this particular example, I've created a VPC network called as VPC network 3. So if I go back to my console, you can see that there's a network called VPC network 3. So to remove this particular VPC network 3, you can just run the Terraform destroy command. I'll say yes. And what this particular command will do is it will remove that particular VPC network 3 from GCP. So let's wait for this to finish. So that resource has been destroyed. So let's go back to our console. So if I refresh this particular page, you can see that VPC network 3 no longer exists. So this is a very important command, and make sure if you're running your configuration or your Terraform in your local environment just to test, then you should always remove those resources once you've finished running them using the Terraform destroy command. So I'll see you in the next lecture.
Now let's talk about the HashiCorp configuration language, also known as HCL. Now HCL consists of arguments and it consists of blocks. Now, of course, we can write our configuration in JSON as well, but I highly recommend that you write it in HCL instead because HCL is much simpler to understand and it's much simpler to learn as well. So let's talk about arguments. So arguments can consist of an identifier and an expression. So here in this particular example, the identifier is image underscore ID, and the expressions can be of the following types. It can be a string, a number, a boolean, or it can be of a complex type, that is a list, a tuple, or a map or an object. Now these primitive types and complex types are something that I will teach you when I'm teaching you about variables. Now let's talk about the block. A block is of the following syntax. It consists of a block type and a list of block labels. Now, based on what kind of block type it is, there will be a corresponding set of block labels. And then it is followed by a curly braces, and within that are a set of arguments. Now, these are the same arguments that we talked about in our previous slide. Now, let's look at an example of a few block types. Now, the most important block type is the Terraform block type. And this particular block type has 0 labels. Another block type is the resource block type. And this resource block type has 2 labels. So here in this example, the block label is the Azure RM resource group. And the next block label is example. And then comes the variable block type. And this variable block type has got one label called as availability zone names. Now here is a very common example of a Terraform configuration file. It consists of a provider block followed by a provider configuration block. And after that comes the variable block, the resource block, the data block, and the output block. Each block I will teach you in the subsequent lectures. So suffice to say that your entire configuration file is basically a set of blocks. Now this is something that you have to keep remembering, that configuration file in Terraform is basically a set of blocks.
So let me reiterate again what I have said. HCL consists of arguments and it consists of blocks. Now your argument consists of an identifier and an expression, and together both of them form the argument. And then a block, and then comes the most important thing, the block. So the block consists of a block type and then a set of block labels based on what kind of block type it is. And within the block are a set of arguments. And each configuration file in Terraform is basically a set of blocks. So that's about it. Now this is a very important chapter and I hope you go through it a few more times. And it's a very short chapter, but it's very important to remember all the points that I have reiterated in this particular chapter. So as you begin your journey in Terraform, there will always be the complications with regards to correct syntax. Now there is a command called Terraform FMT that makes sure that your syntax is proper. So you can always use this command, especially if you are worried about the syntax. So let's look at this particular block. So this is a Terraform block and I have my curly braces in the next line, which is an incorrect syntax. So let's run the Terraform FMT and let's see what happens. So it says that an argument or a block definition is required. To set an argument, use the equal to introduce the argument. So what it says is that it considers this as an argument and not as a block. That is because your curly braces is in the next line. So what I'll do is I will just change it to the same line. So now let's run the Terraform init again. So Terraform FMT, sorry, again. So now you can see that there was no error. Another important factor is basically the differentiation between a single quote and a double quote. So a single quote is not allowed here. So let's just change this to a single quote and let's see what happens. So I'll run the Terraform FMT again. It says that it's an invalid expression. So again, to make it work, you have to change this to double quotes. I'll run the Terraform FMT again. And this time it works and it validates. So the next chapter is going to be an assignment in which I have a few questions with regards to the validity of the syntax. So you can use the Terraform FMT command to check whether that particular syntax is valid or not. So meanwhile, I'll see you in the next section. So I'll see you there. So let's talk about the variable, the local and the output block. So here I have, for the sake of simplicity, considered my main.tf to be a function, and this particular function can be considered a function in any language. So if this particular function takes in an argument, then that argument that it takes in is basically the variable block. So here, for example, I have created a variable a, and that has a value of test. Now let's assume that you want to create a variable that scope is only limited to your main.tf. Then you would create a local block. So for example, here I've created a local block called a that has a value of 100. Now let's assume that you want to return your function to another module, for example. Then you can use an output block. So for example, here I've created an output variable, and this particular variable I have defined as var.a. So that basically means that it will take in the value of 100 that I have defined in my local. So based on this, you could consider the input variables are like the function arguments. The output values are basically the function return values, and the local values are basically functions temporary local variables whose scope is just based or defined within that particular function. So now let's dive into some more theory about the variable block. So the variable block has the following arguments. It has the default. So you can use the default to set values for your particular variable. This is an optional block. Then there is the type. So the type defines what type of variable it is. So there are the following options that you have. You have string, number, boolean, list, or map. Now I will give you examples about these types in a later lecture. You can also set a description about that variable, which again is an optional block. You can also set validation for the values of that particular variable. And you can also have a sensitive argument in your input variable. So you can use this if you do not want to display your output for that particular variable in the output field or in the output block. Now inputs can be defined either in your main.tf and your variables.tf. Now there's a distinction between defining variables and assigning values to them. So this is basically where you define your particular variables. You can either define them in your main.tf or in your variables.tf. So I will show you an example later on in this particular section as to using both main.tf as well as using variables.tf. Now, once you've declared your variables, you can assign values to them as well. So there are multiple ways in which you can assign values. So the most important ones are using the /var command when you're running the Terraform apply command. So you can have a /var option where you can actually assign values to the variables that you have defined. A second option is using the .tfvars files. So within .tfvars files, you can assign values to variables that you have already declared in your main.tf or in your variables.tf file. You can also assign variables using the environmental variables. So the precedence is also as follows. The environmental variable has the least precedence, and using the /var command has the highest precedence. Now let's look at all the types of input variables. There are three kinds of input variables. There is the string, the number, and the boolean. Apart from that, the other types include the complex types, which can be of either collection types or the structural types. So if you're using collection types, then it consists of lists, maps, and sets. So you use collection types when you want to allow multiple values of another type to be grouped together as a single value. And you use structural types when you want to allow multiple values of several distinct types to be grouped together as a single value. So one important distinction is whenever you're using a structural type, then you also need to mention the schema for that particular type. Whereas for collection types, you do not need to mention the schema. You just can mention what type it is. So these types I will explain using examples. So let's go ahead and let's see the examples in the next particular chapter. Okay, now let's talk about creating some variables and displaying it as output. And we might also talk about a few local variables or define a few local variables. So let's start with the most basic. So we have the primitive type of string. So let's create those variables. So before we create them, we need to declare them and then assign values to them. So I have a set of files that I have included in my project or in my root module. We have the main.tf. So main.tf is a place where you can declare variables, and you can do the same in your variables.tf file as well. So you can declare variables in either main.tf or your variable.tf. And I also have a terraform.tf where, so here is where you can actually assign values to that particular variable. And the output is where you can store your output that you can display while you're doing the Terraform apply. So let's start by creating the most basic. So let's create a variable of type string. So I will be declaring this particular variable in my variable.tf file. So to do that, let's create a variable block. So I've created my variable. The name of the variable is stringware and it is of type string. So this is important. So the type will always be there, and this is the only mandatory field that is required in variable. So now let's declare a particular value for this stringware. So to do that, you can go to your terraform.tf vares and you can declare a value for that particular string. So I have declared this particular value. Stringware has the value myFirstString. So now let's go to the output.tf. So in the output block, you can display the output of this particular variable. So this particular variable that I have declared in my variable.tf and the values that I have initialized in my tf-vares will be displayed because of this particular output block. So let us run this particular Terraform file. So I'll do a Terraform apply. So it says the changes because this is the variable that I have created. So it will give you this particular as the output. So I will do a yes. And you can see the output. So this particular block, which represents the output block, has the value of this particular variable. That is the variable that you have declared here. That is myFirstString. So let's do our same and let's just change it to a number now. So I'll declare another variable. And this will be of type number. I'll change this to number as well. And here in the terraform.tf, so I will not assign values in the tf-vares. I will assign it using the /var command when I do a Terraform apply. So the only thing I'll do here is I just display it as output. So I'll just copy this. I'll just do a num and the value I will get from here, and I'll just copy it here. So in this particular example, this particular number I am assigning in my variable.tf. I'm sorry, I am declaring in my variable.tf, and the values that I will assign once I run the Terraform apply. So let's do that. So I do a Terraform apply and I do a /var, and for this particular variable I will assign the value 100. I'll do a yes. And you can see that this particular, so if you go to the output.tf, you can see that this particular block of this particular name, that is output num, has the value of 100. So this 100 has come from the /var that I gave when I ran the Terraform apply. And as you know that this particular /var has got a higher precedence. Now let's create another boolean, and this boolean will declare not in a variable file but in a main.tf. So let's do that. Again, I'll declare the output as well. So again, I have declared the output, and instead of the variable.tf, I've used the main.tf to create or to declare this variable, and I have assigned my variable in the terraform.tfairs file. So let's run this again. Okay, so boolean is not the correct type, so I need to change this to bool. So let me run this again. I'll do a yes. So you can see that the boolean output has got a value of true. So this is how you declare simple variables. So in the next chapter, I'll discuss on how we can create complex variables and assign them as outputs. Okay, let's start by creating the complex types. So in the complex types, let's start with the collection type. So the collection type consists of list, map, and set. You could consider list and set to be like arrays and maps to be like JSON objects. So let's start by creating a list. So here I have a list of string and the variable name is list example. So I have declared my variable and let's assign a few values to this particular list. So I'll copy this variable list. I will save this. I will assign values to it in the terraform.tf. So it would be of type, it would be a list of strings. So I can just put some random values here. I have assigned list values to this particular value. So again, you can say that it's an array, and this array contains three values, and each of them are strings. So if you do not assign a string value, it automatically gets converted to string. So let me just get the output for this. So I just copy this. I'll go to my output, and I will assign an output. I will create an output block. I'll call it list. And the value would be variable dot list example. So let me just run this particular Terraform file. I'll do a Terraform apply. So you can see that single quotes are not valid. So you need to use double quotes. So let's go back to our Terraform TFS and let's just change this to double quotes. Again, let me run this. I'll do a yes. So you can see the list has been displayed in the output. So let's assume that you just want to display one particular value, let's say B. So to do that, you can go back to your output file and you can just set it to 1 like you would do in an array. So it starts with 0 and 1 would hopefully give you the value B. So let's run this again. I'll save this file and let's run this again. I'll do a yes. So you can see the list currently has values of just B. Okay, so now the difference between a list and a set is that using set, you cannot do this particular operation. So let's just change this to type set of string. And if I run the same thing again, it will throw an error. So list and set are basically the same. The only difference is set does not have the concept of indices. So you cannot search for a particular value in that particular string like we try to do using the output. So this thing does not work if you're using set. So that's one thing you need to remember. So let's go back to our output.tf and let's remove this. And let's see if we are able to run it again. So let's do a Terraform apply. Do a yes. Now you can see that using your set, you can display all the values. So the only thing that is not possible using set is the concept of indices where you want to just target a specific value. So now let's talk about maps. So in our previous example, we talked about list and set. In this particular example, we'll talk about map. So let's define a map. So a map is basically an object. So to define a map, you can do it again in your main.tf or in your variable.tf. So let's do it in the variable.tf. So I have created a map of type simple map example, and the type is map string. So this particular variable will accept any object that has the value pair of the key value as a string. So once you have created this, once you have defined this variable, let's assign a particular value to it. So the kind of values that you can assign would be something like this. So you have an object, and the object has two keys, and the values are both strings. So this is a perfect example of type map string. So again, in the output, I'm just going to display the same variable. So let's run this particular example. So you can see the output again is just the key value pair. Now, if you want your values in your key values to be anything, whether it's a string, a number, a boolean, then you can change this from string to any. So once you've done that, you can go back to your TF-vares, and then you can just change it to anything. So like, for example, I can just have a subnet 3, and I can set it to a boolean. So I can set it to true, and I can have one more subnet. I'll keep this as subnet 4, and I'll set it to a number. So if I set it to any, that means it will take any value. So let's just run this again, and I do a yes. So you can see that the output is valid. Okay, now let's change it from any to number. So let's see what happens once we do that. So I've changed it from any to number, and if we run a Terraform apply, it'll say that the values are invalid. So if you need to handle a situation where you do not know the type of the inputs, then you can always put any. So that's it for this lecture. In my next lecture, I'll explain to you what an object is. So in our previous example, we had learned about maps. So these maps are key value pairs where the value can either be of string, number, or boolean. That is, they can only be of primitive types. Now let's assume you want to create a map of key value pairs where the value is not a primitive but a very distinct object itself. So how do we do that? So to meet a scenario like that, we have to create an object first, and then what we'll do is we'll create a map of those objects. So let's start by creating an object. So the important thing to remember is that an object is a group of distinct types, and an object should always have a schema associated with it. So let's create a variable of type object. So here I've created a variable of type object, and this object can take two strings as key value pairs, the CIDR block and the region. So if I assign a value to this particular object example, let's see how it should look like. So I'll copy this, and I will assign a value to this. So this has to contain the CIDR block and the region. So I'll just copy this, and the CIDR block I'll just define a value as 10.0.0.0/20, and then it should also contain a region. So I'll just copy this region, and I'll set this to US East. So this is just an example. And I have to put a comma. So now what I've done is I have assigned this particular object example, the value CIDR block is equal to this and the region is equal to this. So let's output this particular value. So I'll copy this, I'll go to my output.tf, and I'll paste that particular variable. So once I've done that, let me just run this particular Terraform up. So you can see that this particular output has these values. Okay, so this is how you create an object. Now, creating an object by itself has no value. What you need to do is you need to create a map of these objects so that the map can not just be linked to a primitive, but it can also be linked to a structure like an object. So to do that, let's go back to our variable again. What we'll do is we will define a map of objects. So what I'll do is I'll just copy this and I'll paste it. And now what I'll do is I'll create a map of objects, and then I'll go back to my terraform.tf, and So what I'll do now is I'll create a map, and these maps will have key values, and the value would be this particular object. So let me just copy this. I'll just have two subnets, and what I'll do is I'll just copy these objects as well, and I'll change it from test. Here I'll change the value as well, so I'll just keep it as 1. Okay, now what I'll do is I will just change this to, I'll change the value of this to map object example. I'll copy this, I'll save this, and I will output this particular variable as well. Okay, let's apply this again. Yes. So now you can see that I was able to create a map of, not a primitive, but a map of objects. So this is how you can use your map and objects, combine them together and get a useful variable created. So I've created a set of assignments. I hope you finish those assignments, because once you've done them, then I'm sure that you would have perfected everything with regards to variables. So I'll see you in the next lecture now. Hi, this is going to be a very short lecture on how or where you can declare and initialize your local variables. Your local variables have to be declared in your main.tf. Here I have an example of initializing a local variable and setting it a value of 100. Now, if I want to output this particular local variable, I have to go to my outputs, and here what I need to do is, instead of where, I need to do a locals. So I will do a local.a, because a is the name of that variable, and if I run this, then the output should return me 100. So let me run this particular. So you can see that the value is 100. So this is how you use your local variables and output them. Just remember that the scope of your local variables is only within your main.tf. So that is one thing you should remember. So I'll see you in the next section now. So now let's talk about a fetch block, which is called as the provider block. So Terraform relies on plugins called providers to interact with remote cloud systems like GCP, Azure, and AWS. Now, to get the latest provider for GCP, there is a particular link. The link I will also mention in the resource below. So once you have your Terraform block within your code, and once you do a Terraform init after that, then it downloads that particular provider. So I'll show you an example of how that works. Now you can also configure your provider. Within your provider, you can mention the project, the region, and the zone. And once you have done that, whatever resource you create would be created within that particular project, within that particular region, and within that particular zone. There is also a concept of alias. Now this particular concept I'll teach you once we talk about the data block. So let's look at an example of a provider and a configuration for that particular provider. Now here is an example of a provider. So within the Terraform block, I have the GCP provider like this. And then I'm configuring my provider. In the configuration, like I mentioned, I can give the project, the region, and the zone. So the project here corresponds to the GCP project. So I can go back to my console and I can open this particular link. And here, this is the particular project ID that I need to mention. So I've copied this and I've pasted it over here. And the region is zone. And the region is US Central 1 and the zone is US Central 1C. So let's suppose I create a virtual machine, then that particular virtual machine would be created in this particular region and in this particular zone. So as you can see that there is only the main.tf. So the first thing I need to do is I need to run the Terraform init to download the provider. So I'll do a Terraform init. And then what will happen is that there will be a file that gets created, a folder that gets created. So you can see that there's a .terraform folder, and within that is basically the provider for GCP. So that's how you use your provider and configure it. So I'll see you in the next chapter. So to get more information about your provider, you can go to this particular link, and this particular link has the code that you need to use your provider. So this is that particular piece of code that you would copy in your main.tf. So you can use this as a reference, and again it has all the documentation as well. So here if you click on the guides, it will show you how you can use your particular provider. So this is a particularly important link that I will paste in the resource section below. So I'll see you in the next chapter. So now let's talk about the most important block in Terraform, that is the resource block. So what are resources? Resources are the most important element in any Terraform language. You could consider a resource in Terraform to be something like a VPC, a virtual network, a virtual machine, a database. So any of those kinds of things can be termed as a resource in Terraform language. And you can use a resource block to create these particular resources. Each resource block describes one or more infrastructure objects such as a virtual network, a compute instance, or even a higher level component such as a DNS records. So let's look at the anatomy of a resource block. So this is how typically a resource block looks like. It starts with the word resource and then comes the resource type. Now here in this particular example, the resource type is Google Compute Network. That means this particular resource type will create a compute network in GCP. Now based on the cloud provider, there would be a set of types and each type would have a corresponding action that it represents. So for example, if you want to create a virtual machine, then you would have a separate type. If you want to create a database, then there would be a separate type. So you have to go through the documentation and see what particular type does what particular work. So here in this example, like I said previously, the Google Compute Network would create a virtual private network in GCP. And then you can also give a name to your particular type. So for this particular type, I've given the name as VPC underscore network. Now, apart from that, your type also has a set of arguments. So here, for example, I have given the name VPC network for the network that I will create. Now, based on the particular type, there would be a different set of arguments. So for example, here, this particular type has just the name as the argument. Now there could be other optional arguments as well, but name is the only mandatory argument that you have to give. Apart from that, each type also has a set of meta arguments. Now that is irrespective of what type you're using. Each particular type would have these corresponding meta arguments associated with it. We will talk more about these meta arguments as we proceed. And once you've finally done a Terraform apply, this particular resource block gets converted into actual architecture. So in our previous example, as we had seen, once you did a Terraform apply, the Google Compute Network would create a network, and you can actually go to the GCP console to see that particular network that got created. So an important question that you would ask is, how do you find the correct resource type? Well, the easiest way is actually just to Google it. So for example, if you want to know how to create a compute instance, then you can just do Terraform compute instance and GCP. So here, for example, I want to know the type that creates an instance in GCP. So what I'll do is I'll just write Terraform create instance, and then I'll just type GCP. So the first output that you would get would be the type that is required to create an instance. So this is basically the type that you would need to create an instance in GCP using Terraform. That's how easy it is. Once you get accustomed to using Terraform, then you can actually just use this particular Google documentation to do the same. But initially, since you are a beginner, I would advise you to just Google it and go through the documentation that way. Okay, I'll see you in the next lecture now. Okay, let's start a resource block by creating the most basic network in GCP, that is using the Google Compute Network. So we'd already seen this previously, so we wouldn't be spending much time on this. So it's basically creating a network, and the name of this network would be VPC Network 3. Let's just go through the documentation and let's see if there are any other interesting attributes for this particular type. So if you go through the documentation, you can see that the name is the only required field. You can also give a description as well as auto create subnet. So optionally, when this is set to true, the network is created in the auto subnet mode, and it will create a subnet for each region. When it is set to false, then it will create a custom subnet. So we'll create a custom subnet in our next module. The default of this is always set to true. So if this is not provided, then it's always set to true. Then apart from that, there is the MTU that gives you the maximum transmission unit for this particular network. The minimum value that you can set is 1460, whereas the maximum is 1500 bytes. Optionally, you can also provide the project as well as the delete default routes on create. So if this is set to true, the default route will be deleted immediately after the network creation. So let's also see the output attributes that we can get. So we can get the ID, an identifier for the resource, the gateway IPv4, the gateway address for this particular network, as well as the self link. So let's get these particular values using the output variable. So here I've created two output variables, that is op underscore ID and op underscore self underscore link. So to get the values, what you need to do is you need to to get the values, what you need to do is you need to give the type. So here again, it's Google Compute Network. And then the name of the particular type, again, it's VPC underscore network. And then you need to give ID and self link. So this is basically the output that you would get. You can also get the gateway IPv4 by just giving this particular value, that is gateway underscore IPv4. So you can just replace this ID with gateway underscore IPv4 and you'll get the gateway IP address for this particular network. So that's about it. So here I'm going to get two output variables. The first one will give me the value of the ID and the second will give me the value of self underscore link. So let's run this particular, go to my terminal and I'll do a Terraform apply. I'll do a yes. Okay, so the network has been created and you can see the output as well. So the ID for this particular resource is this and the link for this particular resource is this. Now, if you go back to your GCP account, you can go back to your project and within the project, you can just search for VPC here. And you can see a VPC network 3 has been created and it has created a subnet in each region. So this is how you create your default custom network using Terraform. So in our next chapter, we'll see how we can create a custom network. So I'll see you there. Hi, in this particular chapter, we'll again create a VPC network, but unlike the previous chapter where we were able to create auto subnets within each region, we will explicitly create two custom subnets. And these subnets would be one in US Central 1 and the other one could be in any other region. You can also specify a separate CIDR block. And once this particular network is done, as an assignment, what I would want you guys to do is create a firewall rule that would allow ingress of TCP/22 so that we can create a virtual machine in our next chapter and we should be able to connect to that particular virtual machine. So let's see how the code looks like. So let's go through our code. So the first thing you'll notice is that I have created a variable called subnet, and this subnet is basically an object which contains a CIDR block and a region. So it's a map of objects. That means it will contain multiple objects of this variety. So this is where I've defined my variables, and this value has been assigned in my terraform.tfs file. So if you go to the terraform.tfs file, you can see that I have two objects. The first object is named as subnet 1 and the second object is named as subnet 2. So this is the key, and the value for subnet 1 is CIDR block which has an IP range and then a region as well, and similarly for subnet 2 as well. So the first thing again what you need to do is you need to declare a variable and assign it values. And after you've done that, the next thing you need to do is you need to, like previously, create a network. To create a network, you need to do the Google Compute Network resource block. And this resource block, I have named it as VPC network. And the name for this resource block I have given is VPC network custom. And again, the only difference from the previous chapter is that I have to assign the auto create subnet equal to false. If I don't do this, if I set this to true, or if I don't set this at all, then there would be auto subnets that get created in each region. I don't want that. I just need subnets to be created based on the variables that I have given here. Okay, so the next thing what we need to do is we need to create the subnet. For that, we'll use the meta argument called for each. And this for each will have the value of the subnet variable that we had created previously. Now, because this variable subnet has got two entries within it, this particular resource block would be looped twice. And within each of the loops, it will create one resource, and each resource would take values based on the values of the variable within subnet. So for example, it will use the key of that key value pair to create the subnet name, and similarly the IP CIDR range and the region as well. And the network would basically be the ID of the network that we had created in our previous resource block. So again, it's basically the Google Compute Network, the VPC network, and the ID that is set as the output when this particular resource block executes. So the key, let's go back to our Terraform TFS, would be subnet 1. So this would be the name, this would be the CIDR block, and this would be the region. And again, like I said previously, it will loop twice to create two subnets. So let's run this particular Terraform configuration and let's see what the output looks like. Again, I'll do a Terraform apply. I'll do a yes. Now, if you go back to your console, you can see that the VPC network custom network has been created, and it has subnets within two regions, that is US Central 1 and Europe West 2. So this is how you create your custom subnets. I will be linking the code in the description of the resource below, so you can just go through the code if you have any issues. But you can also get in touch with me if you have any issues. So I'll see you in the next chapter. So now let's talk about a very important file that is created when you do a Terraform apply, and that is called a state file. So here you see that there is just the main.tf and the provider. So let's do a Terraform apply and let's see what happens. Okay, once you do a Terraform apply, you can see that there is a .tf state file that gets generated, and this .tf state file is called as the state file, and this has all the information about all the resources that have been created. So for example, if you open this file, it will tell you that there was a VPC network that got created by this particular name, and it will give you all other information as well. And apart from the resources, it will also tell you about the outputs that got generated. So for example, here there were two outputs that got generated. One was the ID and the other one was a self link. So this is a very important file, and this file gives you all the information about all the resources and the outputs that got created. So let's make some changes to our main.tf file and let's see what happens. So here what I'll do is I will rename this particular network from 3 and I'll rename it to 2, and let's do a Terraform apply again. I'll do a yes. So the second time when you do a Terraform apply, you can see that there's a backup.tf state file that gets generated. Now this .backup file contains all the previous configuration, and the current.tf state file contains the present configuration. So if you look at the current.tf state, you can see that the name of the VPC is VPC network 2, and if you go to the backup, it will show the previous one, that is VPC network 3. So these are the two main important files, that is the .tf state and the .tf state backup. So the backup contains the configuration, the previous configuration, and .tf state contains the present configuration. Now these two files are extremely important and they should not get deleted. So if by chance these files get deleted, then your Terraform loses all information about the resources that it has created. So let's try to do that. So if I delete this particular file, I'll delete this one as well, and then I do a Terraform apply again. So it will throw an error saying that this particular network already exists. Now that is because our .tf state file had got deleted and got recreated again. So it is very important for you to always preserve your .tf state file and make sure that it doesn't get deleted. So I'll see you in the next lecture. So in our previous chapter, we were able to create a network with two subnets, one in US Central 1 and one in Europe West 1. In this particular section, with the use of data blocks, we'll be able to create a virtual machine in one of those subnets. And we'll be creating it in Europe West 1, that is subnet 2. So before going into the code, let's look at what a data block is. So what is a data block? A data block allows data to be fetched or computed for use somewhere else in Terraform configuration. The use of the data sources allows a Terraform configuration to make use of information that is defined outside of Terraform or defined by some other Terraform configuration. So what we intend to do in this particular lecture is make use of the Terraform configuration that we had used in our previous section. So in our previous section, we had used a Terraform configuration to create a network. So in this particular section, we'll create another Terraform configuration, and in that Terraform configuration, we'll get information about the network that we had created in the previous one. So in this particular slide, I will show you the data block that we plan to use. So in our previous section, we had created a VPC network. Now to get information about this about that particular VPC network, we need to use the data block. And the data block that we need to use is the Google Compute Network data block. Now, the data block is just like the resource block, but the only difference is that the data block is used to get information about infrastructure that has already been created. So here again, the name of your type would be the Google Compute Network. And the name that I give for my particular type is get underscore network. And the parameter that I need to give for my data block is basically the name of that particular VPC network, which is VPC hyphen network. And in the output, I need to use data dot instead of resource dot that I would have used had this been a resource block. And again, I need to mention the type, the name, and then at the end, I need to mention subnetworks underscore self underscore links to get information about all the subnets for that particular network. So if you look at the bottom, you'll see an example of the output. So the output comes as a list of all the subnets within that particular network. So let's look at a live example now.
Now let's go through our code. I have my main.tf and nothing else. Again, it's the provider that I've initially declared. And here for the provider config, I have two provider configs. The first provider config is for US Central 1, and I have created an alias provider. The alias is Europe West 1. And the only difference between this provider and the one above that is the regions and the zone are different. So my first provider is in US Central 1, and I have my second provider in Europe West 1, and I'll be using this particular provider to create my instance. So I keep going down, and here I have created my first data block, and this data block is for the VPC that I had created in my previous section. So this is basically the VPC that I had created, and using this data block I'll get all the information that I need creating my particular instance. So let's keep going down. Now here comes the most important block again, the resource block. Now this particular resource block is using this particular provider. So this provider is pointing to the second alias that I had previously created. The alias is google.europewest1. As you can see, the alias that I had provided for my second provider was Europe West 1. So this is how you can access multiple providers, that is using the alias. So apart from, so here most of the parameters that I'm giving are actually required. So for example, the name is Terraform-instance. So this will be the name for my virtual machine. The machine type is F1 micro, and the boot disk is basically, this is a boot disk block that is there within this particular resource block. And here I need to provide the image, and the image is Debian Cloud Debian-9. So that means that I'll be installing a Linux distribution. Now, apart from that is the network underscore instance. Now, this particular block tells you that in which particular subnet and in which particular network you want your virtual machine to be in. So here within the network, I'm providing the name of the network, and this name I get from the data block that I had previously created. And I can also mention the subnet name. So the subnet name again is basically using the data block again. And here I'm using the subnets underscore self underscore links. And this returns a list. And this list has two values because there are two subnets. And I'm using the second value from the list. The second value is the subnet that is there in Europe West 1. Now, this is not the ideal way to do it, but just for the sake of this demo, I'm doing it like this. Now, if you're running it in production, you shouldn't be using values like this. Now, just for the sake of demo, I'm just hard coding it. Now, apart from that, there is nothing else. So these are all the mandatory fields that are needed. So I'll be distributing this code in GitHub. So you can always use that, and you can always get in touch with me if you have or if you need some help. Meanwhile, let me just run this particular configuration. So let me do a Terraform apply. I'll do a yes. While it's being created, you can always go back and check the documentation for Google Create instance, sorry, Google Compute instance. And if you check the documentation, you'll get all the information relevant to each particular field. So if in case you want to create an instance based on a specific configuration, then you can always go look into this particular page. I will send a link to this page in the description and the resource below as well. So you can see the resource has been created. So I go to my console again. So let me go to my virtual machine. So you can see that my virtual machine has been created in Europe West 1C. So this was picked up from the provider, and Again, let's just see if it's F1 micro because that was what we had provided in the configuration. So you can see that it's an F1 micro as well. So this is how you can create an instance in Terraform. Okay, so before I conclude, let's do a Terraform destroy as well so that we don't incur any extra cost. Always make sure that you destroy the configuration that you do not need once you're done with it. So the resource has been destroyed. Let's go back to our page and let's see whether that particular resource still exists. So if I refresh this particular page, you can see that it has been removed. So that's how you create an instance. So I'll see you in the next lecture. In this particular chapter, we'll talk about creating a static website in GCP. Now, to create a static website in GCP, you need to create a cloud storage, and that cloud storage should be named as the domain or the URL that you want to create the static website. So for example, I want to create a static website called www.verylazykoders.in. So my cloud storage bucket should also be named the same, that is www.verylazykoders.in. Now to create a cloud storage with this particular name, you have to register this particular domain in Google. So how do you register your domain in Google? So to do that, we'll go back to our GCP console. You can go to your IAM, and within IAM, you can click on identity and organizations. So here you'll get a link to your admin.google.com. So you can just click on this. And here there's a subsection called domain. So here you can add a domain. So you can add a domain here. So I already have added my particular domain here. That was the reason why I was able to create a cloud storage bucket by this particular name. If I do not have this verified, then I will not be able to create a bucket by this particular name. So it is imperative and it's important for you to know that. So the next thing we do is we'll create an index.html file as an object and we'll import that particular bucket into our cloud storage. And once we have done that, the third and the most important thing we do is we will give that particular object and all users access so that everybody is able to access our website. So these are the three steps that we need to follow. First thing is we need to create the bucket. The second is we need to upload the object. So the object here is the index.html file. And the third thing is we need to give permissions so that everybody is able to view that particular file. So let's look at the code. So now let's have a look at our code. So we have two files, the index.html file. So this will be the main page of our website. And then we have the main.tf page. So in the main.tf page, there are three resources that get created. Now the first is basically the Google storage bucket. So this particular resource is to create the bucket. And the bucket would be named as www.verylazykoders.in. And you need to add a location. So the location I've given is US Central 1. And you also need to add uniform bucket level access as false because you do not want to give each object within this particular bucket the same kind of access. You want to give the index.html, for example, access to all users, but not all the files within that particular bucket. Then we have the website block. In this particular website block, we need to give the suffix for the main page. Here, the main page would be the index.html page, and the error page is 404. You can additionally also give CORS permissions. So after you've created the bucket, the next thing you need to do is you need to create an object within that particular bucket. So to create the object, you need to use the Google Storage Bucket object. And then you need to give the name for that particular object, which would be index.html again. And then you also need to give the source. So the source is basically the resource file that I have in my local, which is again index.html file. And then you need to give the name of the bucket within which you want your object. So this name corresponds to this particular bucket that I would just create. So after you uploaded the object, the next thing you need to do is you need to give access control. So what you need to do is you need to give this particular object, so that is the object that you just created, a role of reader and for entity all users. So once you've done this, you've actually given permissions for all users to have read permission to this particular index file or this particular object. So let's run this particular configuration and let's see what happens. So my Terraform apply is done. So let's go to our URL and see if you're able to access our website. So again, it will be www.verylazykoders.in. Of course, there is no SSL, so I'll just proceed without SSL. So you can see that this particular hello world was displayed. So this is basically what is there in our HTML file. And that is how you create a static website. I'll attach the corresponding code in the resource or in the description below. So I'll see you in the next lecture.
So let's see how we can create a cloud function in Terraform. So to do that, the first thing I need to do is I need to create a bucket. And within this bucket, I need to store the code base for my particular cloud function. So I will create my code base in my local and I will upload it as an object into my bucket. So once I've done these two steps, the third step I need to do is I need to create that particular cloud function and I need to point the object in the bucket to that particular cloud function. So that would be the third step. And the fourth step would be to give everybody access to invoke this particular cloud function. So overall that there would be 4 resources that we would be creating and each 4 resources would be of separate types. So let's look at our code base. So the first resource that I'd be creating is the Google storage bucket. So this particular resource type is just to create a bucket. So the bucket name would be this. So once I've created the bucket, like I said previously, the next thing you need to do is you need to create an object. And within this object, you need to upload the code that you want the cloud function to run. So here the name of my object would be index.js and the bucket name is just the same bucket name that I had created previously. So again, it's Google storage bucket, the type, the name of the particular type and the name of the bucket. So this will give you return. So this will return you back the name of your bucket. And then the source points to the code base in your local. So the code base here is the index.zip file. And this index.zip file, if you unzip it, it will contain an index.js and a package.json file. So this index.js just returns a hello world back to the user. So it's very basic, nothing special about it. So once you've created your object and your bucket, the third resource block you need to use is the Google Cloud Functions function. So I will give you a link on the documentation about this particular resource type in the description below. So once you call this particular resource block, you need to give it a name. So the name is function-test. You can give it a description and you also need to mention the runtime. So because we are running a index.js, it has to be a Node.js application. You can also mention the available memory. So the memory that I want to give to this particular function is 128. Then you should also give the bucket and the object. So this object contains the source code for your particular cloud function. So the trigger underscore HTTP is true. That means it will be an HTTP invoked function. And the entry point is hello world. Now this is very important. This particular hello world should correspond to the name of your function that you've created. So the name of my function is hello world and this represents the entry point for your particular function. So your main.tf should also have that same value of hello world. So once you've created your function, the fourth thing you need to do is you need to give an IAM access to this particular function. So to do that, you have to call the Google Cloud function underscore IAM underscore member. Now this particular resource block will give permissions to this particular cloud function that I have created in my previous step so that anybody can invoke it. So the member here is all users and the role is invoker. So anybody can invoke this particular cloud function and that's about it. So these are the 4 resources that we'll create. Now let's run this particular Terraform configuration file. So the next thing I'll do is I'll go back to my console. So this is that particular function that got deployed. I'll click on the trigger tab and this is basically the URL. So you can just open this URL and it should give you the hello world. So this is basically the code that corresponds to the index.js file that we had in our folder. So it basically ran this particular piece of code. So that's it for this particular lecture. And one important note is whenever you're creating infrastructure or architecture, always make sure to have a diagrammatic view of it before you create it. It will make things much easier for you. So I'll see you in the next lecture.